hope everybody had a good weekend and survived prom and enjoyed your prom activities. Hopefully everything went well. But we still have 2 weeks left here of class. 2 weeks left. Once again, I will grade both sets of finals, first semester and second semester, and that will be your final for this class. We will have one more quiz next week in this class. This quiz will not go into the University of Findlay grade. This quiz will just be for your Downton High School grade. Okay, so it does not get applied to University of Findlay at all because we have covered everything we need to cover for Findlay. Okay, we did the college algebra the first semester. We did trigonometry the second semester. We covered everything. Now, just for your information, if you go to college and you get into the math programs in college, and you have to take pre-calculus. Okay, what pre-calculus is when you get to college is they combine both the trig and what we did with the college algebra together in one semester, which means it puts it a really fast pace. Okay, and that's your pre-calculus world. Most of you, if you're going to take Calc 1 here next year, we offer that through the University of Philly still. You can take Calc 1 here next year and then continue on. The hope is that it depends on what you're going into in college, but my hope has always been for some of the majors that you go to in college, whatever you take here at high school for University of Findlay and College Credit Plus will be your top end of mathematics. Now, if you're going to become a doctor, you're going to become an engineer, that's a different story. And you're going to have to advance a little bit more than just Calc 1. But if you're going to be an elementary teacher, you're going into nursing, you're going into the life science field, Calc 1 or pre-calculus or the Calc 1 will be your top end mathematics that you have to take. So translation to that is, when you go to college, you will never have to take a math class again. If you're taking statistics through College Credit Plus here, that's next off your list of things you have to do. So the hope is if you're going at a major that's not math specific, that will help you and assist you in regards to not having to take any other math. If you go and venture into the math field, this was just sent to me over the weekend. If you plan on going into a math field, a math based field, mathematics, or in any type of STEM, and you go to the University of Findlay, okay, you will get a $5,000 scholarship going to the University of Findlay. A scholarship, if you're plan on becoming a math major or something in the math fields, they will give you a $5,000 scholarship out of the University of Findlay. So if you're ever interested, in doing that, if you're a senior or if you're an underclassman, they have monies there for students that are going out there to be able to go to the University of Findlay, and they'll provide extra money for that for you. Anyways, today what we're going to start talking on, we'll go through this week. We'll finish up the beginning of next week or the middle of next week with a quiz. We have sequences and series. Sequences and series. When we talk about sequences, if we take a look at, I have some geometric shapes here. We have a hexagon, hexagon, circle, 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 hexagon, hexagon, circle. What would be the next three objects? I want you to draw in your next three objects. And once again, we're tapping into your elementary, trying to follow patterns, or middle school, try to follow patterns. Yeah. Seth, what's our next three shapes?
Of shapes.
Yeah.
Circle, circle, diamond.
Close. Would that be a tiny diamond?
I don't know what it is.
Or we can maybe advance our vocab and say that would be a hexagon.
Probably.
There we go. We'd have a circle, circle, then a hexagon. Okay, that follows a pattern. If I have the numbers 3, 7, 11, 15, what are the next three numbers? 3, 7, 11, 15. What are your next three numbers, Nick? 19, 23, and 27. How did you magically come up with this?
Because they're all added by 4.
Yeah, we continue to add 4, add 4, add 4, add 4. So we have to continue that pattern by adding 4, adding 4. 5, 6, 8, 11, 15, 20. What's our next three? This one may make you think a little bit harder, but still should be something you should be able to handle. Anna?
26, 33, 41.
How did you magically come up with those numbers?
We're adding 1, but then we're adding 1 to what we're adding. So it's +1, +2, +3, +4, +5.
So to 20 we have to add 6. To add 26 we have to add 7. Then we have to add 8. That would be a pattern of numbers. 3, 6, 12, 24. What are the next numbers we have with this? Ian, what do you have?
48, 96, and 192.
How did you get that?
We're just doubling the number that we have.
When we double, we multiply by 2 to get to the next term. Okay, so these are patterns of numbers. When we talk about a pattern of numbers, we can label this as a sequence. When you deal with patterns, you deal with sequences. In the idea of sequences, we also have clothing that we can call sequences, which are patterns that are on clothing. So whenever you talk about a pattern of anything, you're talking about sequences. A term is a member of a sequence. Okay, so when you talk about a term, we have a member of a sequence. And a term is denoted by a lowercase letter and a subscript of the term number. So we have a lowercase letter and a subscript of the term number. Where A1 would be our first term, A7 would be our seventh term. I will use A's, I will use G's, I will use T's. T1, T7, just tells us our term number. So the subscript tells us what is our term number. Our seventh term, our first term, whatever term number we have. When we talk about an arithmetic sequence, this is called an arithmetic. It's not an arithmetic sequence. Okay? The arithmetic sequence is a pattern of numbers such that a term and its previous term has a common difference. A pattern of numbers such that a term and a previous term and its previous term has a common difference. So you have a pattern of numbers such that a term and its previous term have a common difference. So T7 minus T6 equals T4 minus T3. Okay, if I subtract a term from its previous term, I get a common difference, which will equal T4 minus T3. It will be a common difference. So when you subtract a term and a previous term, we get the same number. In a geometric sequence, is a pattern of numbers such that a term and its previous term has a common ratio. A term and its previous term has a common ratio. So T4 divided by T3 equals T6 divided by T5. You take a term and its previous term, and this will come down to a common ratio, a same number. Well, I gave you 3 numbered sequences at the top. Okay, go up now and describe the sequences as arithmetic or geometric or neither. Arithmetic, geometric, or neither. And Leo's first one here. Arithmetic, which means the common difference would be what? 4. Once again, we have to take a term minus the previous term, and we should get the same value. Second one, arithmetic, geometric, or neither. Alex? Says neither. Because if I would take 6 minus 5, I get 1. I get 8 minus 6, we get 2, so it's not arithmetic. And then we can start and divide. 6 divided by 5, 8 divided by 6. These are not equal either. Third one, Alex, what do we have? Cross? Geometric. Common ratio?
2.
Because 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So if I take a look at the sequence, 4, 7, 10, 13, what type of sequence do we have there? What type of sequence?
Arithmetic.
It's arithmetic with a common difference of 3. Well, if I have a geometric or arithmetic common difference of 3, we want to know what the 10th term is. Well, I give you term 1, 2, 3, and 4. Well, I can keep adding 3 to find my 10th term. I can continue to add 3 to try to find my 500th term, but that's a lot of work. That's a lot of work to be able to come up with the 10th term and the 500th term. Well, if we take a look at term 1, bless you. Term 1 is a value for term 2. What do we have to do to term 1 to get to term 2? Anna?
Add 3.
Add 3. To get to term 3, I could take my term 2, which is 7, which is 4 plus 3. And then we would have to add another 3. So to get to my third term, I have 4 plus 7, which is, or 4 plus 3, which is 7. Then I can add 3 to that to get me my value of 10. To get to our fourth term, we could take our third term and add 3 to it again. Well, our third term is 4 plus 3 plus 3. And then we have to add another 3 to that. Well, mathematically, I can also write this as 4 plus 2 times 3. I can write this as 4 plus 3 times 3. So if we start to look at our pattern here, I have my first term here, T1. My T1 is there. To get to my third term, I have to add on 2 3s. To get to my fourth term, I have to add on 3 3s. So to get to our 10th term, we could take our first term. How many 3s would we have to add to get to our 10th term? Ready?
That's right, 9.
Which one? 9. So if I would take 9 of these 3s and add them together, we get 4 plus 27, or 31. To get to my 500th term, we can take our first term. How many 3s do we have to add to get to our 500th term, Jacob? 499. So now I can clickety-clack into my calculator, 4 plus 399 times 3. $15.01. $15.01 there. I guess I left space here to do that. So if we take a look at a general formula to come up with an nth term, we take our first term, which is here, we add to this our common difference, and then we multiply this by one less than the term number we're trying to find. So we can multiply it by n minus 1. This is our term number we're trying to find. So if I had trying to find term 500, I have 500 minus 1 or 499 there. I have my common difference of 3, and we add that to our first term. So to find a general formula for an arithmetic sequence, to find the nth term,
You also do t minus the difference and then plus just dn. Because that would be getting rid of the n minus 1. And you're doing like what's left over of 0.
but if you subtract it, so if we would look up to what we just did here, you say our first term minus 3 times
3 times 500.
3 times 500. Okay, so that gives us 1500, negative 1500.
4 minus 3 plus the 3 times 500.
4 minus 3
Yeah.
times what then?
3 times 500. Gives you 501. Or 1500.
So you're throwing, oh, you're saying t plus 1. So you're taking,
That's just the way I did it in my head. I don't know why.
so you're saying 501. But then you have, this is a negative quantity.
No. I was just doing 4 minus 3 plus 3 times 500.
He's doing the same thing, he's just doing it in a different order.
Yeah.
I think you said you found like the 0th term.
Yeah.
And then you would add
And then
that.
I add that to like finding the difference and then what you would get at 0. And then adding that to.
Mathematically, it comes out the same. Yeah, that's fine.
That's just.
Yeah, everybody's brain works just a little bit differently and sees something a little bit differently. So if we have a sequence 8, 2, negative 4, negative 10, we are still arithmetic. Need to find a common difference. What is our common difference here? Savannah, what's our common difference? Negative 6. We take a term and subtract off the previous term. Okay, so you have to take a term and subtract off your previous term. We have negative 6, negative 6. What's the 101st term? Find the 101st term. Check your answer with somebody around you. Check your technique on this one. Going. Get the same?
Yeah.
Bless you. If FIFO we get negative 500 what? 92. You get 592. Good with that? Okay. So you manipulate something a little bit differently, and you can work it, which is fine. I would just write out mathematically what you're writing there.
Okay.
All right. We look at a geometric. We look at the geometric. Our first term is a value of 3. Okay, we have a common ratio here. Our common ratio is what, Phoebe? So our first term is a value of 3. To get to our second term, we have a value of 6, so we have 3 times 2. To get a 6. To get to our third term, we can take our second term and multiply by 2. So our second term is, once again, 3 times 2, and we can multiply this by another 2, and that will give us our value of 12. To get to our fourth term, we take our third term and multiply this by another 2, and we come down to our value of 24. Well, if we take a look at this mathematically and use some mathematical principles, we can also write this as 3 times 2 squared. This is 3 times 2 to the third power. So if I'm looking for the 13th term, if I'm trying to find my fourth term, I multiply 3 times 2 to the third. To get to my third term, I have 3 times 2 to the second power. To get to my 13th term, how many 2's do we have to multiply by to get to the 13th term, Corbin? 12 of them. So we take our first term of value of 3 times 2 to the 12th power, and this would give us term 13. So once again, I can clickety-clack it through the calculator and get a fairly big number. Carson, what do you get?
12,288.
12,000 what?
288.
12,288. And if we take a look here, this is our first term. This is our common ratio. And this is 1 less than our term number. So we can do a general form for geometric as Tn is equal to T1 times R to the n minus 1 power. Okay, if we take a look at the next one, we have 2, 3 halves, 4 thirds, 5 fourths. If I subtract the values, previous term or term from a previous term from a term in front of it, or I deal with some division there, do I get a common ratio or a common difference? Do we get either? No. So this is a neither arithmetic nor geometric. But we still want to find a general formula for this sequence. Well, if we take a look at our sequence, and it's writing them all as fractions, when t equals 1, I have 2 over 1. When I have t equals 2, I have 3 over 2. When I have t equals 3, I have 4 over 3. When I have t equals 4, I have 5 over 4. So if I'm looking at Tn here, let's first off look at our denominator. If we look at each part individually, numerator, denominator, when T1 is 1, my denominator is 1, T2 is 2, denominator is 2, and so on. So when T is equal to n, what's our denominator going to be here? N. N. If we take a look at our numerator, t is 1, we get 2, t is 2, we get 3, t is 3, we get 4, t is 4, we get 5. Or, yeah, t is 4, we get 5. Tristan, what do we do here? Add 1. So we have n plus 1. So we can still come up with a general formula. We cannot sit there and come up with a formula to have define a term number per se, but we can have a general formula. So if I was looking for the 50th term, my 50th term would be 51 over 50. So I can find a term number that way, or a term number that way. Once again, this is the very basics to sequences. Not sure if anywhere in your curriculum you've seen the idea of sequences.
Oh, we did this in 8th grade.
Did you find your term number or term member?
Yeah.
Well, what we will utilize this is then a little bit of review for you. We will start dealing with series. We'll deal with recursive formulas tomorrow, and then we deal with series, which will be looking at a sequence and adding terms of our sequence into a series. So this will be a progression in regards to what we are doing here. Sort of save this for the end, because it's not very stressful.